Hi, this is chapter 10 and 12 on linear regression. So here's an example. Suppose that we have data for a certain plant and we have here the age in months and then here's the height in inches. So say these are 5 plants and we want to find out the correlation between these data, and we want to apply linear regression to model this set of data. And suppose that the average, in this case, we can calculate the average age and turn out to be 4 months. The SD for the age is 2 months. The average for the height is 7 inches, and then the SD for the height is 4 inches. Now, if I were to plot this on a calculator, then notice that this is very close to this line, and so the linear correlation turns out from the calculator is 0.95. And so we want to find the linear regression, which is the line that best describes this linear data. And so we want to find the slope of this line and also the y-intercept. In fact, it turns out that the answer is right here, but we'll have to calculate these as part of the problem. So here it is. We want again, the linear coefficient is 0.95. So we want to find the linear regression. So here's the first problem. Find the linear regression. Y is mx plus b. So we need two things. We need the slope m and a point on the line. And so the easy part is that a point on the line is again, this is the point not on the line of, again, there's no line that goes to all these points. We want to find the line that best describes these points. And so it turns out that that line has the point of averages. So the average of x and the average of y. So for example, the average of x is 4. The average of y is 7. So 4 comma 7 is on this linear regression line. So that's the easy part. And then now the next part is to find the slope of this regression line. And from the textbook, the slope is given by the correlation coefficient r, the standard deviation of y divided by the standard deviation of x. So this product gives you the slope of the linear regression. So in this example, the linear correlation is 0.95. So we have here 0.95 times, and we know that the SD of y, which is the height, the SD is 4. So we have 4 divided by SD of x. So the x variable in this case is the age. So the SD is 2. So this is the slope of the line. So 4 divided by 2 is 2. 2 times 0.95 is 1.9. So that's the slope of this line. So therefore the equation of the line is, so y is equal to 1.9 x plus b. So we need to find the the b. Well, how do you find the b? Well, we know the slope. To find the b, we just need to pick a point on the line, which is this point, and then plug it in for x and y, and then find b. So in this case, the x value, the y value is 7, is equal to 1.9 times x is 4, and plus b. Therefore, b is equal to 7 minus 1.9 times 4. So let's do that. 7 minus 1.9 times 4 is negative 0.6. So b is negative 0.6. So the linear regression is y is equal to 1.9x minus 0.6. So that would be the linear regression. This equation is the equation of that line. Notice the slope is 1.9. The y-intercept is negative 0.6. So that's what the calculator had, and our calculation shows that it's the same thing. For part B, we're going to use this linear regression. We're going to use this line that best describes the data to make prediction. So in this case, we want to predict the height of the plant if we know that the age is 6 months. So we know the x value for 6, we know for x is 6, we want to predict the height that corresponds to 6. Notice we don't have the data for 6. So we use this equation and we plug in 6 for x. So that means y is equal to 1.9 times 6 minus 0.6. Right, this is from this equation right here, where x is now 6 months. So if I do that, I get 1.9 times 6 minus 0.6. So you get 10.8. So that means that 10.8, and this is in inches. So that means that at 6 months, the prediction is that it's approximately 10.8 inches. And then lastly, we want to talk about how do you interpret the slope of this regression line. 1.9 is the slope of this regression line. How do I interpret that? Well, here's a quick example. So slope is rise over run. And so let's just put the numbers in here. So rise over run. So rise is 1.9. Run, we can make it 1. So again, the slope is 1.9, which is the same thing as 1.9 over 1. Now 1.9 represent the rise, which is the height in inches. So this is 1.9 inches, and the run is 1 month. Right. This is the y is the inch, the height. The x is the age. So 1.9 is the same thing as 1.9 over 1. If we look at this, we notice that, so that means that based on the regression method, we predict that for every 1 month in age, then the plant grows about 1.9 inches. So that's what the regression method tells us, right? Is that based on this data, for every 1 month that you increase in age, you go up by 1.9 inches. So that's how you interpret the slope. So for example, if you want, you can also do this. You can say, what if you want to look at, so here, insert a math equation. What if I want to look at 2 months? What if we increase the age by 2 months? That means that the height is 2 times 1.9. Okay, notice this fraction is the same thing as this fraction, where you cancel the 2 here. So this says that if you increase your age by 2 months, then the plants grow by approximately 2 times 1.9, or 3.8 inches. Right, so 3.8. So that's how we interpret the slope of the regression line. It tells you approximately how high the plant will grow for every 1 month increase in age. And if you do this for 2 months, then you have to double this. If you do this for 10 months, so you want to know how much the plant grows in 10 months, and you multiply this by 10. Okay, this should be enough for you to do the workbook assignment on chapter 10 and 12, which is on linear regression.